Find all zeros and a complete factorization of p of x equals x cubed plus 7x squared plus 18x plus 18. Despite the fact that there are 4 terms, if we try factoring by grouping, it's just not going to work out. So we're going to have to use the rational zeros theorem to figure out the potential zeros. And from there, we'll have to try those potential zeros using synthetic division to see which one actually works. Because the leading coefficient is 1, that means that the potential rational zeros are the factors of 18. However, there are 12 factors of 18, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. Now, I'm not going to go through and demonstrate all of these possible zeros, but I will do 2 of them so you can see an example of one that doesn't work and an example of one that does. Let's start with 3. We'll use synthetic division to test this. Our coefficients are 1, 7, 18, and 18. So we bring down the 1. 3 times 1 is 3. 7 plus 3 is 10. 3 times 10 is 30. 30 plus 18 is 48. 48 times 3 is 144. And 144 plus 18 is 162, which is definitely not 0. Though there's something interesting that happens when we try 3. Because all of these coefficients are positive and 3 is positive, when we multiply and add, all we have are positive numbers, and so there's no way we're going to end up with 0 in the end. In fact, this is true for all of the other positive possible rational zeros as well. So we can tell immediately that the rational zeros are going to have to be negative. So let's try -3 and see if this works out better. We start by bringing down the 1. 1 times 3 is -3. We add to get 4. 4 times -3 is -12. We add to get 6. 6 times -3 is -18. We add and get a remainder of 0. So we know that -3 is a 0 of this polynomial, which tells us that x plus 3 is a factor. And when we factor that out, the remainder is going to be x squared plus 4x plus 6. At this point, we cannot easily use unfoiling. There aren't 2 numbers that multiply to 6 and add up to 4. So again, we need to use the quadratic formula. So when we do that, we've got the opposite of b, which is -4, plus or minus the square root of b squared, which is 16, minus 4 times a times c, all over 2 times a. Now, underneath that radical, this is going to end up being 16 minus 24, all over 2. Now, 16 minus 24 is going to give us -8. And when we go to simplify that, we're going to do a couple of things. First, whenever we have the square root of a negative number, we can pull that negative out as an I. And then we can split up 8 into 4 times 2. And the benefit of this is that the square root of 4 is equal to 2. So this is going to be -4 plus or minus 2 root 2i all over 2. And when we divide both of those terms by 2, we get -2 plus or minus root 2 times I. So our zeros are going to be -3, which we found earlier, -2 plus root 2i, and negative 2 minus root 2i. Now we know that each of these corresponds to a factor. Negative 3 corresponds to x plus 3. Negative 2 plus root 2i corresponds to x minus negative 2 plus root 2i. And negative 2 minus root 2i corresponds to x minus negative 2 minus root 2i. And of course, to simplify things, we need to distribute those subtractions in each of the factors. So we end up with x plus 2 minus root 2i and x plus 2 plus root 2i. And this is the final factorization of our polynomial. So we've got that, we've got the zeros, and we're good to go.